we're going to review sequences and series. And I have the challenge of not having a graphing calculator at home with me, so I will do the best I can. So S sub 20 using the summation on a calculator. So I can show you what you would be typing in. It's under the math key, and you scroll down to the sigma notation. First of all, you should be trying all of these problems by yourself first and just using this video as a resource to check your work. So I'm going to go from 1 to term 20, and then what's the pattern? 7 plus 3 times n minus 1. On your calculator, those will show up as x's instead of as n's. All right, so I'm going to check my answer using just the formula. So I should get the same answer that you get from typing this in. If there are 20 terms, there will be 10 pairs. I know the first term is 7, and I need to generate the 20th term because that will be the last term. So if I plug in 20 into my formula here, I'm going to have 7 plus 3 times 19. So 7 plus 3 times 19, my last term would be 64. And if I take 10 and multiply by 7 plus 64, I should get 710. So you can double check my answer using the summation on your calculator. Okay, so the next problem is about the geometric series, and it's infinite, which means it goes on forever. So I have to be using the formula for a geometric series that's infinite and that converges, meaning it gets smaller and smaller. So you can see that the ratio is times 1/2 every time. And so the formula is a sub 1 over 1 minus r. So in our case, a sub 1 is 50. And 1 minus 1/2 is the denominator because r is times 1/2 every time. And so that simplifies to 50 divided by 1/2. And when you divide by a fraction, you flip it and multiply by the reciprocal. 50 times 2 will be 100. So if I add it together every single term forever, including the smallest of decimals, this will eventually converge to 100. This says find the common ratio and the sum of the first 4 terms and determine if it will converge or diverge. So if I plug in 1, 2, 3, and 4. If I plug in 1, I would get 3/9, which is 1/3. If I plug in 2, I would get 9 over 9, which is 1. If I plug in 3, I would get 27 divided by 9, which is 3. If I plug in 4, I would get 81 divided by 9, which is 9. So it says find the sum of the first 4 terms. So 9, 12, 13 and a third. If I added them together, will this converge or diverge? This is getting bigger and bigger because I'm multiplying by a ratio of 3, so it would diverge. Find the common ratio and the sum of the first 8 terms. Round the answer to the nearest thousandth and determine if it will converge. So the common ratio is 0.75. The sum of the first 8 terms we could do on our calculator from 1 to 8, and then we can just type the 20, the 0.75 to the n minus 1. This should all be inside your calculator's parentheses. And then it says, will it converge or diverge? It's going to converge because you're multiplying it by something less than 1 every time. 0.75 as much, 0.75 as much, 0.75 as much. So when I type that into my calculator, let me see what I get. So I just typed it into a graphing calculator on my computer, and I got 71.9909. This is the 10ths, hundredths, thousandths place. So 71.991 would be rounded to the nearest thousandth. Find the sum for the infinite series. So infinite, they're just making this go on forever because we just said that it converges. So it is the starting value of 20 over 1 minus r. So in this case, 20 divided by 1/4, because 1 minus 3/4 is 1/4, is the same as 20 times 4. So the answer would converge at 80. So at the first 8 terms, I'm not quite getting there yet. I would probably have to go out 20 terms to see that this is getting closer and closer to 80. Find the sum of the first 5 terms of this sequence. Determine if it's arithmetic, geometric, or neither. So I'm going to generate the first 5 terms and then add them together because I have to figure out which one it is. 4 times, and then 1 squared is 1. So 4 times 1 is 4. 4 times 2 squared, and 2 squared is 4. So 4 times 4 is 16. 4 times 3 squared is 9. And 4 times 9 is 36. Let's see, 4 squared is 16, and 4 times 16 is 64. And 5 squared is 25, and 4 times 5 is 100. So this is times 4, but this is not times 4. And this is plus 12, but this is not plus 12. So this is a neither. And if I found the sum of these terms, I could add them up. And I get, let's see, 20 plus 36 plus 164, I get 220 as my sum. All right, so you should be pausing this in between every question. Find the sum of the first 10 terms. So this is going to be, it looks like, let's see, is it times 0.6 as a ratio? So what is, yeah, because 6 times 0.6 is 3.6 times 0.6, 2.16. Okay, find the sum of the first 10 terms. The sum n goes from 1 to 10. My starting value is 10, and I'm multiplying by 0.6 to the n minus 1 power. So I'm going to do that on my graphing calculator on my computer. You were going to try it. So mine came out to 24.849 or 24.85. Okay. All right, find the sum of this infinite series. It looks like we're multiplying by what? Times negative a half times negative a half times negative a half. So my R value is negative a half. All right, so I'm going to take a sub 1 over 1 minus R because this is infinite. So 80 divided by 1 minus negative a half. 80 divided by 1.5. So what is 80 divided by 1.5? It is 53 1/3. So this is going to converge to 53 1/3. Find the sum of this infinite series. So you can see that this is going to be 0.999999999, which actually converges to 1 when you add together infinite 0.99999s. All right, number 10, Joe needs 1,500,000 for retirement. He's investing money each month in stocks. How much does he need to invest each month? So this type of application problem is not going to be on your quiz, but this is a good one to practice geometric, and I'm going to help you with the formula. So we're doing compounded monthly, right? So we are doing a summation. It's 30 years compounded monthly. So n goes from 1 to, what's 30 times 12? Is that 360? Oops. 30 times 12 is 360. So 360 times he's going to put money in every single month. How much does he need to put in every month? We don't know. And then 1 plus the interest rate divided by 12 months, raised to the n minus 1 power. So that's going to plug in month 1, plug in month 2, month 3, month 4, month 5, all the way up to month 360. This is what I want to solve for. So you could guess and check this amount. We're going to see a shortcut that we're allowed to set our problem equal to the 1.5 million and divide by the summation. But for now, you don't know how to do that. So we are going to guess and check what x is on the calculator. So let me give you kind of a parameter to check between. All right, so let me give you a hint so you can zero in on the answer. As you guess and check, I would start with the number 1,200 because it's actually more than $1,200 every single month, or maybe use the table on your calculator to figure that one out. All right, the next one, this one we should be able to set up. They take 200 milligrams of pain medication and 40% dissipates in 1 hour. So how much is in the bloodstream after 1 hour? 200 times 60% would be left, right? Because if 40% is gone, then 60% is left. So 120 milligrams will be left. And then how much medication is there after 2 hours? So then I would take 120 and multiply by 0.6 again. So I would have 72 milligrams. And then how much medication remains after 6 hours? So this was after 1 hour, 2 hours. I'm essentially taking 200 times 0.6 to the 6th, right? Because it's dissipating for a total of 6 hours. 200 times 0.6 to the 6th. About 9.33 milligrams remains after 6 hours. All right, Trevor. Trevor just signed a 7-year professional football league contract. His base salary is $2 million, and management gives him the following options. So we want to find the total value of the option. So which one should Trevor take? So is he going to take his base salary for the 7 years plus an additional bonus each year? So that would just be 7 years times 2.1 million, right? So what is 7 times 2.1 million? You can do that out. Or does he want an annual increase of 4.5% beginning after year 1? So we want to add up all 7 of his salaries from year 1 to year 7. He's starting with his base salary of $2 million. And how do I show that it's going up by 4.5%? Multiply by 1.045 n minus 1 times. So that will give you the first year when you put it in, you just get $2 million. The second year when you put it in, you get 2 million times your raise for just 1 year. Then the third year is going to be 2 million with this number squared, and then 2 million all the way up to the power of 6 to represent his 6 raises. All right, and then what about an annual increase of just 95,000 per year? So that's arithmetic, right? So I think you can set that one up. Good luck.